Assalamu alaikum. So this chapter talked about, chapter number 3 talked about low pass, high pass, band pass filters. It talked about space domain filtering, which included both point processing and mask processing. Now, towards the end of this chapter, we're moving towards frequency domain filtering. And it really goes back to the fundamental concepts that if you have any periodic signal, as in the cases here, it can be represented as a Fourier series as a sum of sines and cosines. And the more frequency, higher frequency components you take, the more closer it looks to the original signal. And this case, for instance, is a periodic signal. Now, if I sum up this green, yellow, pink, blue, and blue, all these different frequencies, all these signals, if I superimpose them on one to another, they will start looking like this signal. Now, extending the same principle of decomposing a signal into its Fourier coefficients or its Fourier components is done for an image as well. Now, image is two-dimensional in nature. It has both x and y component, and we did study in chapter number 2 the two-dimensional discrete Fourier transform where you try to obtain the u and v components. Here it's referred to as L and K, but the u and v, they're equivalent components, the Fourier spectrum of the same. So here, for instance, this is an image where you have a two-dimensional image which is converted into its Fourier spectrum. This is the frequency components in one direction, and this is the frequency components in the other direction. Now, going back here, you can see there is a J component, there is an imaginary component, so there is both magnitude and phase. That's what's important to understand, that there is a magnitude and there is a phase. In other words, there is a directional component there. You can also take the inverse discrete Fourier transform, and this is how you take it. So the whole point is that if you take an image, you convert it into its Fourier spectrum, then you apply the low pass or the high pass. Low pass are smoothing filters. We've seen before they have a smoothing effect. High pass filters are sharpening filters. They sharpen the edges and textures. They are responsible for highlighting the edges and textures and removing the rest. So you convert them in the image into a Fourier spectrum, you pass it through a filter, and then you go back. In other words, you take an image, you get the Fourier spectrum, you pass it through the filter. If it's a smoothing filter, it's a low pass filter. If it's a sharpening filter, it's a high pass filter. And then you obtain the inverse Fourier transform and you get the image back, the output or the resultant image back. In case of a low pass filter, this is how a typical low pass filter, ideal low pass filter looks like. You have u and v components, and the low pass filter allows everything whose frequencies components are present within this cylinder with radius d naught. Now d naught is obviously the radius, and it's represented here. So any signal whose DUV is less than the cutoff frequency is allowed, but beyond that it's not allowed. Here is an example of low frequency pass filters, low pass filters with increasing radiuses. So 5, 15, 30, 80, and then 230. This is 230, this is 80, this is 30, this is 15, and there's a small one which is 5 here. Now, let's see what happens if you pass an image through filters, through low pass filters with increasing magnitude. Obviously, bigger the radius, more the higher frequency components are also allowed. So if you look at this image, now this image contains a lot of edges because it contains a lot of these words. It contains a lot of lines, and all the background is in fact your low frequency component. Now if you pass it through a low pass filter of radius 5, the whole thing is smudged out because you're not allowing any high frequency component to pass through. Therefore the whole thing smudges out. But as you increase the radius of the low pass filter, now you can make out some of the, you can in fact make out some of the writings which are present in the original image. People who wear glasses, for instance, if you remove their glasses, those who have perfect eyesight wouldn't know what it really means, but people who have bad eyesight, who wear glasses, usually see things smudged out. So if somebody is wearing a very strong, powerful lens, he actually is kind of like, his eye is more of like a low pass filter, which is smudging everything out, and it has to be improved so the images are sharpened. In some sense, you can think of it this way. So as you increase the radius of the low pass filter, you can see that the writings become clearer and clearer with larger radius, because now you are allowing the high frequency components to pass through, therefore which ensures that the textures are retained and you have the writings coming out clearly. Now an ideal low pass filter is difficult to obtain, so you use a Butterworth low pass filter. This is how a Butterworth low pass filter looks like. It is allowing low frequency components. You can see it doesn't have a very sharp transition. It has a transition which is smoother from what is allowed to what isn't. And this is how it looks like. And here is an electron microscope of an integrated circuit. In a low pass filter, the images are smoothened out. In a high pass filter, everything except the texture is highlighted, but everything else is somewhat removed. So an application of the low pass filter is that if you have an image, you tend to, these marks which are underneath the eye, they are smoothened out if you use a low pass filter. So the image, the face looks fresh in some sense, because all these wrinkles are removed using a low pass filter. Another example of using a low pass filter is that if you have a scan of a page which is several years, that you took several years ago, and some of these words are broken up, if you pass them through a low pass filter, it somehow smoothens it out and you can read the different characters more smoothly. A high pass filter is the opposite end. In other words, it doesn't allow low frequency components, but it does allow high frequency components to pass through. So this is what the low pass filter looks like. This is in two-dimensional domain, so it looks like a cylinder, a circle, and here is the same image. So if you increase the diameter of the radius, you see that the image becomes sharpened, but all the low frequency components are removed. So that's why high frequency, high pass filters are called sharpening filters, whereas low frequency filters, low pass filters, are called smoothing filters. Now this is an ideal pass filter, high pass filter. If that's usually hard to obtain, so you use a Butterworth high pass filter. Notice that the N here is the order of the Butterworth filter. Now we discussed that in the last lecture, the generic form. And if you want to see, I would suggest you go back to the last lecture and see how that looks like. Now, one interesting thing is that this 0 and this 1 are flipped. Similarly, look at the coefficients of Butterworth low pass compared to high pass. So this is your high pass filter, this is the Butterworth high pass filter. Now this is your Butterworth low pass. See, the coefficients are reversed, right? So this is your Butterworth low pass filter, and the same in a high pass filter. Obviously the transition here is smoother, and it makes sense. This is one example where you would be using, this is the original image, this is the high pass filtering result. Again, not much is visible here. Again, this is what you do after histogram equalization. Notice a lot of things become clearer from the original image to the one that you see in the bottom right after doing histogram equalization. Now, we did discuss histogram equalization in the previous lectures, so I would recommend you go back and have a look at this. In some sense, chapter number 3 was all about pre-processing. Whether it was point processing, mask processing, histogram equalization, frequency domain filtration, you're really trying to come out, you're really trying to bring out things which are important, things which are worthwhile looking into, which may not be visible in the original image. And the entire chapter 3 is basically pre-processing. I hope, thank you very much for listening. Inshallah ta'ala, next time we're going to talk about chapter number 4. Until next time, thank you very much. Assalamu alaikum.